Good day everyone. Today we're going to tackle about pressure. The air around you has weight and it presses and touches everything. That pressure is called atmospheric pressure. When we say atmospheric pressure, it is a pressure that wind significant controlling the Earth's weather and climate. And sometimes wind and exists because of the horizontal and vertical differences of pressure, which means by that it is caused by the Coriolis effect, which means it is all about the weather patterns here on Earth. Example, the weather patterns are the tropical cyclones or storms. Next is the atmospheric pressure. When we say atmospheric pressure, it is the force per unit of area. Just like what I've said earlier, it has weight, it contains weight, and it presses and touches everything in the Earth's surface. Wherein, Earth pressure is a measurement in millibars. Millibars, it measured millibars commonly, it measures 1013 millibars or equivalent to 1 kilogram centimeter of square of Earth's surface. Barometers. Barometers are used in measuring atmospheric pressure, where namely Torricelli's barometer and the aneroid barometer. This was invented by Evangelist Torricelli, wherein Torricelli's barometer, it is an experiment of Torricelli's emerged a tube sealed at one end into the container of mercury, wherein there's a tube contains a mercury inside, wherein when the air pressure rises, the mercury also rises on it. So this is the example of the Torricelli's barometer, wherein the air pressure, the mercury, and air pressure. When the mercury rises, the air pressure is higher. So the second one is the aneroid barometer. An aneroid barometer uses a coil of tubing with most of the air removed, which means it uses coil. When the coil bends inward, it means the air pressure rises. When it drops out, it means the low pressure drops. So this is example of the aneroid barometer. Basic pressure system. Pressures varies from day to day life here on Earth. Earth is not equally heated by the sun, and there are some places here on Earth which is warm air, often have low pressure systems, and some parts here on Earth have higher pressure systems. Low pressure systems, also called as depression, those usually associated with high winds, warm air, and atmospheric lifting. Under it produces clouds, precipitations, and turbulent weathers. These turbulent weathers, such as tropical storms and cyclones, which sometimes caused by this Coriolis effect. This Coriolis effect is weather patterns here on Earth that affects the weather and the climate of Earth. So next one is the higher pressure systems. The high pressure systems is sometimes called anticyclone. Why anticyclone? Because the sinking air, when the sinking air ascends here on Earth to the ground, to the surface, it travels through the Earth's surface and affects the climate and weather of the Earth. And then, when it affects the weather and the climate of the Earth, it goes to the northern hemisphere and pushed clockwise, and on the other hand, when it goes to the southern hemisphere, it pushed counterclockwise. To sum up, high pressure systems are generated or can be denoted as capital H, and lower pressure systems is capital M.
Good day everyone, my name is Renz Jerome Balading, and today we're going to talk about the features of high pressure systems and low pressure systems. So here are some of the features. First, we have fair weather. High pressure systems are generally associated with settled weather. It is a fair weather when there are clouds in the sky. The clouds cover the big part of the sky with occasional rain showers, and wind blows gently. On the other hand, low pressure systems bring dark clouds, precipitation, and stormy conditions like thunder, lightning, strong wind, and heavy rain. So here's the example of low pressure system. Kindly observe. While this one is an example of high pressure system. Next features are sinking and rising air. High pressure systems entails sinking air, while the low pressure systems entail rising air. So here's the example of high pressure system and low pressure system. High pressure system, sinking air is associated with clear, calm condition and good weather. While on the other hand, in a low pressure system, rising air is associated with dark clouds, precipitation, and rain. The next features are the wind flows of high pressure systems and low pressure systems. In high pressure systems, the air flows clockwise, while on the other hand, in the low pressure systems, the air flows counterclockwise. So here's the picture of high pressure systems and low pressure system. In high pressure system, the air flows clockwise, while on the other hand, in low pressure system, the air flows counterclockwise. The next feature is the lifespan and movement of high pressure systems and low pressure systems. The slightly inward moving air in low pressure causes air to converge, and since it can move downward due to the surface, the air falls upward, leading to condensation and precipitation. The opposite occurs with high pressure. The air is moving away from the high pressure center at the surface, or diverging. So as the result, air from above must sink to take its place. So we are done discussing the features of high pressure systems and low pressure system. Now, I'm going to show you a video about the features of high pressure systems and low pressure system in order for you to go beyond and understand its concept.
Changes in atmospheric pressure have a significant effect on the phenomena that occur in the Earth's atmosphere. The pressure and temperature measurements conducted in different meteorological stations, or data obtained from a meteorological satellite, make it possible to create synoptic maps, which illustrate the distribution of pressure. This information enables us to discover the direction and strength of the wind and areas of high and low pressure. In areas of high pressure, the air pressure is higher than in the surrounding areas. What is important here is not a particular value of the pressure, but the relative change in the pressure. Where the pressure is high, the air sinks. As this happens, the air becomes warmer, which prevents the formation of clouds. That is why an area of high pressure is usually associated with good weather. In areas of low pressure, the air pressure is lower than in the surrounding areas. Again, it is the relative change in pressure which is important. Low pressure is created in areas where the air is rising. The rising air then cools, which can trigger the condensation of vapor and the formation of clouds. When the amount of vapor or ice stored in clouds is sufficiently high, it will begin to rain or snow. That is why areas of low pressure are usually associated with bad weather.
So now let's proceed to the factors affecting air pressures. First, we have temperature. As the temperature increases, air expands, because of which its density decreases, which result in low pressure. On the other hand, air shrinks due to low temperature, because of which its density increases, which creates high pressure. Next is the height from sea level. Air pressure is created due to weight of air. Therefore, sea level has the highest air pressure. As we move forward from sea level, leaving behind the heavy gases at lower layers of atmosphere, air pressure decreases because the upper air is light and its density is low. the height of 5 kilometers from sea level and the height of 11 kilometers, it is reducing to 1/4. It is because of low pressure in mountainous regions. Next is the moisture in air or humidity. Conversion of water from liquid state to gaseous state because of evaporation is known as atmospheric humidity. Water vapors are light in weight. Therefore, they are raised up and pressure of humid air decreases as compared to dry air. Amount of water vapor changes with time and places, and because of this, the pressure of air also varies. Next is the gravitation of Earth. Atmospheric glues around the Earth due to its gravitation. The intensity of gravitational pull decreases as we get away from the core of the Earth. Another fact is that Earth rotates around its axis. Average distance of polar regions and equatorial regions varies from the core of the Earth. Last but not the least is the rotation of Earth. Rotation of Earth produces centrifugal forces which has more effect in the equatorial region while lesser effect on polar regions. Centrifugal forces pushes things away from its core. Same is the effect on air pressure which result into a lesser pressure in equatorial regions as compared to that in polar regions. So this is the end of my topic. My name is Renz Jerome Balading. Thank you for listening.
Good day everyone. To continue our report, we have the distribution of air pressure. So distribution of air pressure on the surface of the earth is not uniform. It varies both vertically and horizontally. It varies from time to time at a given space, and it varies from place to place over short distances. It is mainly because we have the differences in temperature. So the mass of the air above in the column of air compresses the air under it, and hence its lower layers are denser than the upper layers. So as a result, the lower layers of the atmosphere have higher density, hence exerts more pressure. So take a look at this illustration. So as you can observe, the higher the altitude, the lower the pressure. The lower the altitude, the higher the pressure. So first, we have the vertical distribution. So air pressure is highest at sea level because the density of gases is highest in lower layers. So the density changes due to the expansion and the air shrinks because of the low temperature. So the air pressure and the height are reversely proportional to each other, which means that air pressure decreases due to the increase in height. And conversely, the air pressure increases due to the decrease in height or the altitude. So we have here the illustration. So as you try to observe, we have the highest pressure in the Earth's surface or in the troposphere. But as you go higher, the altitude drastically decreases. So why? When the air is being heated, the air would decrease its density. And once it decreases its density, the particles will become much more sparse or loosely packed. And once becomes loosely packed, there is a decrease in pressure. So next, we have the horizontal distribution. The distribution of the atmospheric pressure over the globe is known as the horizontal distribution. So in horizontal distribution, we have to take note these three factors which is responsible for the variation in the horizontal distribution of the air pressure. We have the Earth's temperature, air temperature, the Earth's rotation, then last we have the presence of the water vapor. So the horizontal distribution mainly is the four pressure belts. So we have the equatorial low, subtropical high, subpolar low, then polar high pressure belts. So this is the illustration and the distribution of the horizontal distribution of air pressure. First, we have the equatorial low pressure belts. These areas in the Earth's equatorial region from 0 to 10 degrees north and south is composed of warm light ascending and converging air. So the sun shines vertically almost throughout the year on the equator. So as a result, the air gets warm and the air gets warm and rises over the equatorial region, and it produced the equatorial low pressure trough. Then this is also called the intertropical convergence zones because the winds blowing from subtropical highs here will converge in that area. This is also called the doldrums because this region of, the zone of calms. We have the calm conditions here. The second pressure belt, we have the subtropic pressure belt. So located at 30 degrees north and south, this is a zone of hot, dry air that forms as the warm air descending from the tropics. So this area is also, this region is also called a region of divergence because you can see the air pressure, the air is blowing towards the equatorial region and towards the subpolar low pressure belts. Then we have the subpolar low pressure belts. This area is at 60 degrees north and south latitude and features cool, wet weather. The subpolar low is caused by the meeting of cold air masses from higher latitudes and warmer air masses from lower latitudes. This region is also called a zone of the convergence. It is called polar front because the air coming from the subtropical high with the polar high is converged here. Thus, it produces cyclonic storms or low pressure condition. So that's why it's letter L. Then lastly, we have the polar high pressure belts. So these are located at 90 degrees north and south and are extremely cold and dry. So in polar region, the sun never shines vertically but somewhat like slanting. So that's why they have, in polar region, they have a low temperature. And because of the lower temperature, the air compresses and its density increases. So that's why this region is has high pressure. So the air coming from the polar easterlies will blow towards the subpolar low pressure belts. So how does atmospheric pressure affects the weather? Simply, the low pressure generally means cloudy, rainy weather. So air masses move apart, thus the warm air rises and it forms clouds. Thus it also forms a precipitation. That's why we have a rainy weather when we have a low pressure. Conversely, in high pressure generally means fair weather. So air masses in upper atmosphere is layer of air. So warm, moist air cannot rise. So because it cannot rise, no clouds will be formed. No clouds, we have the fair weather. So that could be all about the distribution of the air pressure. Thank you and good day.